Hello everyone, it's Patrick again with Issaquah Robotics Society, and this is another programming video. After today, the goal is to actually be able to get you programming and writing real code, so yay, that's something to be excited about, and today is about classes and object-oriented programming. So, what we have is a world of objects, and what object-oriented programming says, the object-oriented paradigm, says that computers can model relevant tasks as interactions among a system of objects. Think about that. In our everyday life, are we not just objects interacting with each other? If you go into a store, you're interacting with a lot of things. You're picking stuff off the shelves, putting it in your cart, taking it to the clerk. And so we can model complicated real-world situations as interactions with objects. Crucial, crucial, crucial. Alright, so, well, what is an object? That's the big question. Well, objects can have two things. They can have state, so that's information an object stores about itself. And they can also have behavior, so it's a set of things an object can do. And if you think about that, you yourself could be modeled as an object. You have state, that's information, maybe your name, age, birthday, weight, etc. And also behavior. You do things as well. You run, skip, jump, all sorts of good stuff. Okay? So let's look at an example. Here's an airplane. Well, what kind of state might it have? What information does it store about itself? Well, it could be flying or not at a given time. At a given time, an airplane may be flying or not. It may have a certain internal temperature, a number of passengers it's carrying. What about behavior? Well, you can turn on the lights and air conditioner inside the cabin. It can take off, and you can deploy landing gear. So, this airplane, this complicated airplane, we can model in our code as an object with state and behavior, two crucial things. Alright, so how are we going to make objects in code? Well, we're going to use something called a class. Now, a class is a blueprint for a type of object, which is it's a user-defined type of object. Methods let us define our own expressions, while classes let us define our own types. So, a class is not an object itself. Remember, it's the blueprint for that object. Okay? In Java, something to remember is that Java is a pure object-oriented language in that code cannot exist outside of classes. A class is a fundamental basic structure in Java. So let's look at how we might make one. Well, basically what's going to happen is we've got this pattern again when we've got declaring something, we've got adjectives describing a block of code. Okay, so how's that going to work? Well, we're going to declare our class first. We use the class keyword. So this block is going to be a type of thing called a class, and then it's also going to have a name of the class or identifier. And so in this case, we've got a class named tree, and that's going to be defined in these curly braces, which are known as the class body. The class body is a block of code declared to be a class, and this is going to serve as a blueprint for all our tree objects. Okay, so when we're making a tree, we go to the class tree. So now how are we going to model state in a class? We're going to use something in a field called a field. A field is a variable declared in the class body. So right here we've declared a double variable named height. What does that mean? It means that every tree, in the blueprint we're saying that every tree has height, has a height of some kind. Each individual tree's height may change. The pine tree outside may be very, very tall, where the sapling on my sink countertop may be short. But if it is a tree, it will have height. So we've got information that may vary from instance to instance, but that all members have. That's state. And we call this special variable declared in the class a field. Now, this is just a simple example. Your classes can have as many fields as you want. Okay? Many fields. Now, how are we going to model behavior in a class? Well, seems like method would be a good way to do that. Okay? Methods declared in a class are used to model behavior for its objects. So, in this case, what we're saying is we've got this class of tree. It's got a height, but it also can grow. Trees can grow. That makes sense. And the way we model this behavior oftentimes is through changes of state, which are known as side effects. So, in this case, what's happening here? Well, when we call our grow method, our height, this dot height, the height of the tree, is going to increase by a certain amount. So we can model a tree's growth by increasing the height variable that it stores. This will make a little bit more sense in a minute when we start making objects. Okay? So one way to think about this is with a car analogy. Okay? We have engineering drawings. Okay? That was the tree class. We said that trees have height and that trees can grow. But that doesn't help us if we want to actually make a tree that can grow. We would need to make a car from the engineering drawings before we can actually drive any. Can each individual instance differ from each other, from the other ones? The answer is absolutely yes. I can have cars that are red, blue, green, big, small, medium, be convertible or not, but they could all come theoretically from the same engineering drawings. So that's the idea, kind of an instance in a class. Alright? Now, how do we actually make objects? Well, there are going to be two steps. The first is going to be the new keyword. And what that's going to do is it's going to create room for the objects we're creating in memory, because in the computer has to create room for these objects that we're creating. Okay, so we'll have the new keyword. And then we'll have a special method called the constructor. What the constructor will do is it will take that space in memory that we made with the new keyword and turn it actually into an object. Get it ready. Okay? Now the constructor is special because normally we declare a method with return type and then signature. Okay? But with the constructor, the return type and the name of the signature are actually going to be the same thing, and they're going to be the name of the class. So let's look at an example here. When we define a constructor for our we're going to define a constructor for our tree class. Notice in normal methods how we have the signature here, or we have the return type here, excuse me, and then the signature. Okay? We've got a name for the signature and a return type, and those are two distinct things. In a constructor, they're going to be the same, like I said earlier. So in this case, they're going to be tree, because our constructor is going to return a tree kind of object. It's going to take the new memory that we've created and turn it into a tree. And what that's going to be called is creating an instance, which is a member of a class. Now, if you build something from the blueprints, then you can assume that it will follow those designs pretty much to a T. So, a member of a class will come with all of the fields or state that you've defined in the class, and with all the methods or behavior that you've defined in the class. Let's take a look. Here's code that will create a new tree instance. Alright? What's going to happen is two steps. We got the new keyword, like we said earlier. That's called instantiation. It's creating a huge big block in memory to store all of the wonderful fields and technically not behavior, but we can think about it like behavior. We can think of it as storing behavior in this big block of memory. But this is just a bunch of memory. This is not an actual tree. So the second step is to call the constructor method, which we defined earlier in our tree class. What the tree constructor is going to do is take the block of memory that we had now, and from the blueprints of the class that we have, in this case it's the tree class, it's going to create all of the information, the fields that we need to store in the object, and all of the behavior, the methods that we need to store in the object, and actually put them in there. So you can think about this information is actually being stored inside this object. This tree object has the height inside of it, and you can think of it as having a grow method inside of it. Okay? So now, that's how we've now made a tree object from the tree class. We've taken the engineering designs, the blueprints, and we've created an actual car, if you think about it like that. So here we go. Now how are we going to store objects? Because here's the problem. Objects are big, so we can't store them directly into variables like we could with primitives. And keep in mind that primitives are just all the types we've been working with so far. The ones that begin with lowercase, so int, boolean, character, double, all of those. Those are primitive types. Object types begin with uppercase letters. Just something to keep in mind. So how are we going to store objects that are large and big, like we just talked about, into little tiny variables? Well, the answer is we're going to use a reference. We're not going to store the actual object itself. We're just going to store where it is in memory so that we can use it when we need it. It's like when I went to a dance, when I went to homecoming. I didn't want to carry around my jacket the whole time when I was dancing and having a great time party rocking. So what I did was, I turned in my jacket at the desk, and they gave me a little card with a number on it that matched with my jacket. And so what happened there is that instead of having to carry around my big jacket, I just had the little card that I could exchange for the jacket anytime I needed it. So that's kind of the idea of a reference. We're not storing the actual big object itself, we're just storing the location where it is. It's kind of like a calling card in that sense. So that's a reference. Here's an example. Okay, let's say we wanted to create a tree variable. Now notice, this is exactly the same as the variables before, except this time it's of type tree. It's going to be a reference to a tree object. Okay, and we'll see how that works now. So stepping through this line by line, when we say tree maple, we've got type, we've got an identifier. So what that's going to do is it's create a reference to some tree object. Now notice right now, is it referencing any object? No. Okay? No. That's what's going to happen in the second line. We're going to make it reference a new tree object. So there we go. And then we store the location of that tree object inside of this variable here, maple. And so now we've got a maple, a reference named maple, that references a tree object, which is right here, which we created in the second line. So that's how that works. Now something super important and kind of as we're bringing down today, towards the end, one last thing to introduce is the dot operator, okay? And that is essentially the message passing operator. It can be used to utilize an object's state and behavior. Because it's cool and all that we have this nice object, but it would be nice if we could actually do things with its state and behavior. So here's how it works. The left side of the operator is the target or the recipient of the message. So if I have some object that I want to do something with, I say that object and then a dot. Okay? And then on the right side is the message or the desired identifier method signature that I want to use on it. Well, let's see how this works. Here's an example. Okay, so same example as before. We make a reference to a tree and then store the location of an object inside that reference. Now, here is the dot operator. We've got an object on the left and a message, height, on the right. What that's going to do is it's going to follow the reference and get this double height. And now we're going to treat it just like any other variable. We're going to store 10 inside of height. So after this line of code runs, we've got that. Then we call, now we have the same kind of thing. We've got an object reference on the left, that's the target, then the dot message passing operator, and now we pass the message to it, grow. So it's going to follow the reference, find the grow method, and call it. And since it's going to grow 10, now the state of our height is going to be 20. Yeah? There we go. So, with that, here are some exercises. We learned a lot of key terms so far today and in previous videos, and it's vital that you know them. So I made a Quizlet page, do that and learn them. And then find an article about object-oriented programming or test-driven development. I'll let you figure out what those are. And finally, find 3 things around you and look at them and think about their state and behavior and make a list of those things. Okay? And then, from the previous exercise, write a class to model one of the things you chose, more if you're an overachiever. But what I want you to think about is, think about an actual user of the object, then include information only relevant to that person's use of your object. So, if I'm a banana farmer, I might care about a banana's weight, but if I'm a banana consumer, I might care about the calories that it has. So think about things like that. Different people need objects for different reasons, and write your class likewise. And so I want you to also add methods to your class you think your client would like to have. And finally, write code outside your class that shows how you want it to be used, and then make an instance of the class to use it, and then add comments explaining what is going on. So thank you for watching, and you will be ready to program for real, and I will see you next video. Bye.